Hello everyone, this is the fourth video of our course. In this video, we are going to do geometry optimization of our previously prepared graphene structure. Let's check the lattice parameter is almost identical. This is the CASTEP module that we should use. Go to calculation. So now this is the task. Yes, it is geometry optimization. Go to more, and I'm choosing express setting, but you should choose a medium or fine to have the maximum good results. So express settings, go to more, and maximum iteration should be 500, and cell optimization depends on the type of geometry optimization you are going to do, but in most cases it should be full. Okay, close it. Metal here, in this case our graphene is electrically conductive, so it has a metallic nature, so it should be checked. DFT plus U should be unchecked because our structure does not have any d electrons like in transition metal. Spin polarized should be non-polarized, and GGAPB function should be used. And here pseudo potential should be used. OTFG ultrasound, this is fast and most accurate. Okay, go to more. Here the custom energy cutoff should always be 500 in every geometry optimization and energy optimization. These values are hidden because it depends on the quality. So, and this energy cutoff also depends on the quality. So if I change to medium, these options are now available to choose, and go back to express, use custom energy cutoff again 500, go to SCF settings. The SCF cycle also should be 500, and there are two different minimizer like all bands and density mixing. Normally we use density mixing. All bands should be used for phonon calculation. That is another story. Go to density mixing, and the charge should be 0.1 for this particular graphene structure. It depends on the type of structure and the number of elements, the type of element that we're using. Go to K points, and here you see this structure has only atoms in A and B direction, not in the C direction. So create grid parameter like 331, close it. This is the electronic tab that we completed. In the properties tab, uncheck all the properties because right now we are only going to do geometry optimization. The population analysis should be checked because it only tells us about the atomic position and its charges and everything else related to the structure. Okay, go to job control. Now you can name your job like this, like I'm going to do here, demo geometry optimization. And in the next line, you can choose how many cores of your processor should be used. Go to more and update every 5 seconds. Okay, now click run. Now the structure is unsymmetrized and P1, so it's saying you should do it to P1, but we're not going to do it like that. So click no, and the job is started. I fast forwarded this job 10 times so it can complete very quickly. So the job is completed now. Come here to convergence. So there are four parameters that need to be converged below their threshold point. So the iteration level where all the required parameters are below their threshold points, threshold lines, it is converged. So now this is the CASTEP file. Go to the bottom, and this is the time and the overall parallel efficiency rating. This is a H field charge, and you can find also some other good important parameters on this. This is the optimized structure, and in the next video we are going to do single point energy optimization of this structure. Thank you.